Okay, this unit, again, we're going to cover 8.1, 8.2, and 8.5. Actually, all of chapter 8 is on what we call quadratics. Quadratic is any equation that can be put in the form ax squared plus bx plus c equals 0. So this is considered the quadratic term. The whole function, the whole equation is a quadratic equation or a quadratic function. Okay, but this specific term is the quadratic. You have to have an a value, you have to have an x squared. When you have an x squared, you are dealing with a quadratic. Most of chapter 8 is about solving quadratics. Okay, there are multiple methods for solving a quadratic. I'm going to talk about 3 of them. 8.1 covers 2, 8.2 covers a third one. So essentially, we're going to be talking about solving a quadratic. Okay, the first method we're going to use to solve is called the square root method. Okay, this particular method is nice. It's the easiest one to understand. It is the most linear in its algebra solving. It's probably what you're going to be more familiar with. However, it only works in very specific instances. Okay, if your x term basically is 0, if it's gone, if you don't see an x term, that's when we can solve using the square root method. For example, if we needed to solve x squared minus 4 equals 0. Now, if you'll remember, we actually solved a problem like this in the chapter where we did factoring. Okay, we solved by factoring. That's another method for solving. Okay, so if you remember that and you want to solve by factoring, you can. In fact, I'll talk about that here in just a second, but the square root method works really, really, really nicely for a problem like this. Okay, for the square root method, you want to isolate the squared portion. So basically what we're going to do is we're going to move this -4 over to the other side. Remember, in math, if you want to move something, you've got to do the opposite. So if we want to get rid of this -4, we're going to add 4. So x squared would equal 4. And again, in solving equations, you want to get rid of something, you do the opposite. The opposite of squaring something is to square root, hence the square root method. Again, what you do to one side of the equation, you have to do to the other. Square rooting a squared leaves you with just x. Now, when you square root to get rid of the squared, you have to account for something in particular, okay? The square root of 4, okay, this implies the principal root. The square root of 4 is 2. However, you also have to account for something we call the negative root as well. Because if I take 2 and square it, I can get 4, okay? Similarly, if I take -2, the quantity, and square it, I also get 4. So you have to account for both the positive and the negative. So typically the square root of 4 just means to find 2. However, when you're solving and you square root, you have to account for the fact that it could be either the positive or the negative. So it's going to yield 2 different solutions. One way to write that is to just separate them into +2 and -2. Another way to write that, there's a symbol that's a plus and a minus kind of stacked on top of each other, and that means both +2 and -2. My math lab will let you write it either way. I will obviously accept either way. So if you want to write them individually, fine. Want to shorten it and put that little plus and minus out in front, also fine. Perfectly good, totally acceptable. Okay, now they're going to complicate this. They're going to give you some uglier looking problems, but the method is still basically the same. Isolate the squared piece, use your square root to get rid of it, and then account for both the plus and the minus. So the ugliest a square root method problem would be something potentially like this. All right. Again, when it comes to solving using the square root method, okay, again, we want to isolate this squared portion, meaning we want to get this x minus 3 squared by itself. To do so, we got to get rid of the positive 8. Again, to get rid of, we subtract. So 2x minus 3 squareds is going to equal negative 8. Divide by 2. Negative 8 divided by 2 is negative 4. So we have x minus 3 squared equals negative 4. Now, again, to get rid of the squared, we're going to square root, which conveniently wipes out your exponent. So we just have x minus 3 equals. Now, the square root of negative 4. Okay, you don't always get pretty little whole number answers here. In fact, we talked about this last time. Remember, when you take the square root of a negative, okay, that makes your answer imaginary. We are no longer dealing with a real number. We are dealing with a complex or imaginary number. So the square root of negative 4 is like saying the square root of negative 1 times the square root of 4. Okay, the square root of 4 is 2. The square root of negative 1 is that I. So the square root of negative 4 is plus or minus 2i. So then if we go to solve, we're going to add 3 to both sides. Remember, you can't combine a real portion with an imaginary or complex portion. So the correct solution to this is 3 plus or minus 2i. Now, you could, again, write that separately. You could say 3 plus 2i and then 3 minus 2i, but I wouldn't write it separately if I could just write it together. It means the same thing. I'm indifferent. My math lab will actually accept both, but this is a more succinct answer. Okay. And be aware, square roots of a negative, your calculator is not going to do that for you. You do need to understand the square rooting a negative is going to give you an imaginary solution. Also remember, you cannot combine real portions of your solution with imaginary. These are not like terms. They do not combine. This does not simplify. Okay. So let's say we needed to solve this. Very similar. Again, we want to isolate the squared portion. So same game. We want to get rid of the non-squared stuff. So we get negative 4 times quantity 2x plus 1 squared. Negative 6 and negative 2 is negative 8. Divide by negative 4. 2x plus 1 quantity squared is equal to negative 8 divided by negative 4 is 2. Square root that. 2x plus 1 is equal to plus or minus the root of 2. Again, now we want to solve for x. So again, subtract 1. These two things are, again, not like terms, cannot combine, need to divide. There we go. That would be my solution. Now, again, a couple of different ways to write this. And again, my math lab will accept either. Again, I'm perfectly fine with this as a solution. I think that's a great way to write it. You can actually split this up as well. You could do negative 1/2 plus or minus the square root of 2 over 2 if you like that. I'm indifferent. This and this mean the exact same thing. So just pick one. They're both good. Neither is better or more right than the other. Now, the square root method is a great method to solve when you have an isolatable or isolated squared portion with no other x's. Once you include another x, you can no longer use the square root method. Okay, this one has a quadratic term, but now we also have a linear term. So we can't just isolate the squared portion because we're still going to have the variable that we're solving for in the other side. Can't really take the square root of that. It just doesn't solve in the same manner. So this requires a different method. Now, in 8.1, my math lab specifies they want you to solve by a method called completing the square. This is a perfectly fine method, but it's, to me, a little more confusing. And again, especially once you have numbers in front of the x squared, or if you get an odd term in the middle, completing the square becomes a much uglier process. So I'm going to show you how to complete the square, but I'm going to show you in my mind a different method. That's what 8.2 is all about, and it works just as well. And in fact, I think even better. So I'm going to show you completing the square, but then I'm going to change my attention to 8.2, which is solving by the quadratic formula. And really, you can solve any of these using really any method you want, except for when you have a linear term, you can't solve by the square root method. So anyway, to solve by completing the square, I'm going to show you this once. Then again, like I said, I'm going to show you in my mind what a different, better method is. So the first step is to move the constant to the other side. So again, we're going to take this -5, or this +5, and we're going to get rid of it. We subtract 5 from both sides. We get x squared plus 6x equals -5. Now, I'm purposely leaving a space here because that's the step that is going to make this work. Okay. Another term for completing the square is we call this force factoring, because we're going to take something that probably wouldn't initially factor and we're going to force it to factor. We're going to make it factor. So we're going to choose a very specific number to add here. Okay, to complete the square, we're going to take half of this linear term, and then we are going to square it. So half of 6 is 3. 3 squared is 9. And that's what we're going to add to our function. I'll tell you why here in just a second, but for now, just understand that that's what we're doing. Okay, so we're choosing half of 6 squared and adding that here. Now, in math, you can't just add all willy-nilly, okay? If we wanted to get rid of something by subtracting, you've got to make sure and do it to both sides of the equation. Same thing. If I randomly add a +9 over here on the left, I also need a +9 over here on the right. That's the only way these two equations can stay balanced. All right, now if we factor x squared plus 6x plus 9, x squared is x times x, and then what multiplies to get 9 that adds to get 6? Well, that would be 3 and 3, and we knew that because we chose this number. Okay, half of 6 is 3, 3 squared is 9, so 3 times 3 is going to be 9, and 3 plus 3 is going to give you 6. That's always going to work. Okay, that's why this force factoring works. You're always going to get the same number, and it's always going to be half of that middle term. And what's nice is another way to write x plus 3 times x plus 3 is x plus 3 quantity squared. So then if we add -5 plus 9, we get 4. And now we've made it to where we can solve using that square root method. So if we square root plus 3 equals plus or minus 2, square root of 4. Subtract 3 from both sides. There we go. So -3 plus 2 is -1, and -3 minus 2 is -5. These are my solutions to this original function. Now, that's a lot of stuff to have to do, and that's the easiest type of problem. Okay, if you get an odd number, when you go to take half of it, you're going to get a fraction, then you're going to get a fraction squared. It just makes the problem uglier. Also, when you get a number in front of the x squared, you have to factor it out first, and it again changes the process. It becomes a much more difficult scenario. So I'm going to show you a different method, the one that they express in 8-2, and we can do that instead of completing the square. And it is called, so this is 8-2. We're going to solve using the quadratic formula. The quadratic formula is a generic formula that works to solve pretty much any quadratic equation. So again, a quadratic equation Man, I'm sorry. I'm so sorry. But remember, a quadratic equation can always be put into this form. You've got a times your x squared plus b times your x plus c, your constant. Okay, so the number in front of your x squared is your a value. The number in front of your x is your b value. The number out here with no x's is your c value. And if b or c are missing and or are zero, you just put a zero there. The quadratic formula can solve for x. Okay, x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now that looks like a nasty formula. It looks like it's going to be really difficult, but it's just a matter of putting the right numbers in the right place and then use your math to simplify. Okay, I'm going to show you how this works using the exact same problem I just solved using the square. So if we want to solve x squared plus 6x plus 5 equals 0, we can solve using that quadratic formula. So x is going to equal, okay, the opposite of b. So remember, okay, the number in front of my x squared is my a. The number in front of my x is my b. My constant is c. So negative b, so if this was a positive 6, we're going to use a negative 6 plus or minus square root of, so b squared, so that's going to be 6 squared minus 4 times a times c all over 2 times a. And if you have a somewhat sophisticated calculator, you can basically just type this directly into your calculator. Now, you can't do the plus and the minus at the same time, but you can hit your fraction button, and then in the top of your fraction, hit negative 6 plus square root, and then under the square root, you can type in 6 squared minus 4 times 1 times 5, then go down here to the bottom of the fraction, hit 2 times 1, and hit equals, and your calculator should simplify that for you. Now, if you don't trust your calculator, you want to just walk through it, I'll walk you through it, but your calculator will totally do that for you. Okay, in any case, 6 squared is 36. 4 times 1 times 5 is 20. 2 times 1 is 2. 36 minus 20 is 16. And the square root of 16 is 4. So we get negative 6 plus or minus 4 all over 2. So now, because these are all pretty little whole numbers, we can combine all of that. So if we simplify this, negative 6 plus 4 over 2, well, negative 6 plus 4 is negative 2, divided by 2 is negative 1. Negative 6 minus 4 over 2, well, negative 6 minus 4 is negative 10, divided by 2 is negative 5. So we were able to generate the exact same solution. So when we completed the square, okay, x squared plus 6x plus 5, we ended up with solutions of negative 1 and negative 5. Using the quadratic formula, we also generated solutions of negative 1 and negative 5. Same exact problem, same exact solutions, completely different method. okay? I'm not going to specify which method you need to solve. Honestly, I prefer the quadratic formula. I would use it over solving by completing the square. When you solve by completing the square, that's useful in a couple of situations, but for the most part, the quadratic formula does the same thing, just really neatly and concisely and consistently, whether there's a number in front of the x squared or whether the b value is odd or whatever. So I'm going to walk through a few more examples using the quadratic formula just to make sure you understand how it works. So I'm going to rewrite the formula pretty much every time just so you see it. This is not something I'm going to give you. This is a formula that if you want to use, you are going to have to memorize. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so here's another example. Now, I like this example because this is similar to the problem that we were able to solve a couple of units ago where we solved by factoring. This one does not factor, but you can still solve it. All right, so we're going to solve using the quadratic formula. So just as a reminder, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where, again, in the correct order, the number in front of your x squared is an a, the number in front of your x is your b, the number in front of, or the number with no x's, the constant is c. So again, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. And again, if we want to simplify, 6 squared is 36. 4 times 1 times 13 is 52. 36 minus 52 is negative 16. Now, again, pay very close attention. When you have the negative inside of the square root, that makes your number imaginary. This is no longer a real solution. This is a complex or imaginary solution. So x equals negative 6 plus or minus the square root of negative 16. So again, the square root of a negative makes it imaginary. In this case, the square root of 16 is 4. And this would be my solution. Now, remember, before, okay, because these are all whole numbers, we can simplify this. Negative 6 plus 4 is negative 2. Negative 2 divided by 2 is negative 1. When you have an imaginary portion, these two things are not the same. In fact, these three things are not the same. This is real. This is real. This is imaginary. I cannot add negative 6 plus 4i and simplify that. That doesn't simplify. So I can't make this a negative 2i. That doesn't work. Okay. But what I can do is I can still factor, right? So if all three of these numbers, if all three of these numbers are divisible by the same thing, we can divide that number out, or again, we can split this up essentially. So I can do negative 6 halves plus or minus 4 halves I. Negative 6 divided by 2 is negative 3. 4 divided by 2 is 2. So this is my simplified, complete answer to the original problem. So x squared plus 6x plus 13 equals 0. The solutions are negative 3 plus or minus 2i. So that means negative 3 plus 2i or negative 3 minus 2i. Now, I'm going to show you a couple other problems where they try to trick you. Basically, if you're not in the correct form, you might need to manipulate your equation. For example, if they want us to solve 3x squared equals negative 5x minus 5. In order to solve, remember, we do have to get this into the correct form. We need ax squared plus bx plus c equals 0. So we've got to get all of these things on the same side. So if we add a 5x and if we add a 5, we get 3x squared plus 5x plus 5 equals 0. So if it's not in the correct form to start with, we got to get it there. So again, there's my A, there's my B, there's my C. And again, if they have them in the wrong order, remember the x squared needs to go first, then the x term, then the constant. All right, x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, we had an a value of 3 instead of 1, so again, that's going to make this a little different. 5 squared is 25. 4 times 3 is 12, times 5 is 60, 2 times 3 is 6. 25 minus 60 is negative 35. Okay, now the square root of 35 does not break down. The square root of a negative, again, does make this answer imaginary. Not all of the answers will be imaginary, but if you get a negative inside of the square root, it is. Now, different people will put the I in different places. I tend to put it in front so that it's not confused with, if you put it at the end, you want to make sure it's outside of the radical. For example, if you want to say the square root of 35i, it needs to be very clear and obvious that the I is outside of the radical box. If you write it where it looks like it could be underneath the radical, this and this do not mean the same thing. So be very careful of that. For that reason, I tend to put the I in front. Now, don't put it in front of the whole thing because the I is attached to that square root of the negative 35. This negative 5 is the real portion. This is the imaginary portion. Now, because these things are all not divisible by the same thing, we can't simplify that anymore. So these are my solutions. Negative 5 plus I roots of 35 all over 6, and negative 5 minus I roots of 35 all over 6. All right, they do throw a couple of fractions. So I just want to do one of these fraction problems. It's not nearly as scary as it looks. But let's say they asked us to solve a problem like so. So x squared over 7 minus x equals 3/7. Now, what looks like a really ugly, difficult, hairy, scary problem is really not that bad. The very first lesson we did in here when we were solving equations, we learned how to solve equations by getting rid of fractions. When you have fractions in a quadratic, we can easily clear them or get rid of them. If you multiply everything by a common denominator, and in fact, we're going to use the lowest common denominator, we can get rid of fractions. So if we look at our denominators, we got 1 and 7 and 7. So if we multiply everything by 7, so if I take 7 times x squared over 7, I just get x squared. If I take 7 times negative 1, I get a negative 7x. If I take 7 times 3/7, I get 3. So multiplying by the lowest common denominator clears those fractions. So it takes a ugly, scary, hairy problem and makes it not so bad. Anyway, we're going to get our 3 on the same side by adding the opposite. Subtract 3 from both sides. And now this is my A, this is my B, this is my C. So x equals. Now, the negative b, if b is already negative, remember the negative of a negative is a positive. So the negative of negative 7 is just 7. Now, be very careful here because we take b and square it. B is -7, but make sure you put it in parentheses. Okay, if you type in -7 squared, your calculator thinks you need -49. Okay, when you put it in parentheses like it is supposed to be, -7 in quantity squared is +49. Pay attention to that. That's a big deal. Okay, if you have a negative b value, when you square it, it has to be in parentheses. Anyway, 4 times a times c, all over 2 times a. So again, -7 quantity squared is a +49. -4 times 1 times -3, that's +12. All over 2. 49 plus 12 is 61, which doesn't break down. So we get 7 plus or minus the root of 61 all over 2. So when you get one of those fraction problems, remember, it's not so scary. Multiply by the lowest common denominator, and that will clear your fractions. From there, solving using the quadratic formula is not too terrible. All right, the last section, the last thing we're going to talk about, 8.5, no longer deals with solving quadratics, but graphing quadratics. Now, graphing on MyMathLab is really kind of nice. It's kind of paint by numbers, so I'll walk you through how to do this. Again, not too terrible. So we're going to start by graphing the most basic quadratic function, which is just y equals x squared. We actually refer to this as the parent function. It is the most basic quadratic. It's going to show us some of the properties, and I'm going to show you a nifty way we can graph as long as the equation is in vertex form. So if we were going to graph y equals x squared, I'm going to make an xy chart. If I make x 2, okay, squared would be 4. If I make x 1, 1 squared is 1. If I make x 0, 0 squared is 0. So if I wanted to graph those, we get 0, 0, we get 1, 1, we get 2, 4. And actually, if we were to keep going, 3 squared is 9, 5, 6, 7, 8, 9. That'd be way up here. Okay, your graph kind of does that number. If we keep going, we do some negative x's. All right, -1 squared is 1. -2 squared is 4. And in fact, -3 squared is also 9. This graph would look like that. All right, when you graph a quadratic, this shape is called a parabola. So anytime you graph a quadratic, you're going to get a curve that looks like this. Okay, there are a couple of defining values or defining factors about a parabola. This point right here where it changes direction, so we start going down till we get here, then we start going up. This point where we change directions, this point is extremely important. This point is called the vertex. You're going to have to be able to find the vertex if you want to graph a quadratic. While you can make an XY chart, if you're not finding your points around the vertex, it's kind of tough to tell exactly where your graph is and exactly what it's doing. So I'm going to show you exactly how to find the vertex. Also, at the vertex, that literally splits the graph in half. If I draw a vertical line straight up through that vertex, this side over here on the right completely mirrors or exactly matches this side over here on the left. This is called the axis of symmetry. This side of the graph will match this side of the graph perfectly. This point matches up to this point. This point matches up to this point. This one matches to this one. In fact, all these intermediate points match as well. When you graph a parabola on MyMathLab, it's going to ask you to graph the quadratic. So you're going to need to graph the parabola. It needs to be solid. It's also going to ask you to graph that axis of symmetry. You're going to need to draw a dotted line up through the middle of the vertex. It's extremely important that you click on that dotted line to graph the dotted line. If you try graphing it solid, it's going to take away points. You don't want that. Okay. On your final, when I ask you to graph a quadratic, all I want to see is the quadratic. That's all you need to be able to do. But for my math lab, they want you to be able to find this axis of symmetry as well. All right, now this is the parent function. This is the most simple function. I'm going to show you how to find all of that same information if your function changes. This is called vertex form. Okay. These are the things that can change within a quadratic. First, I want to look at the number inside of the parentheses. So if you are adding or subtracting something with x, this shifts your graph left or right. It's going to take your vertex, it's going to grab it from 0, 0, and it's going to move it left, or it's going to move it right. Okay. Now, inside of the parentheses, because this is a minus h, actually moves a little backwards to what you would think. If you see a minus here, that's actually going to shift your graph to the right or in a positive direction, which is weird. If you see a plus symbol here, that will actually shift your graph to the left or in a negative direction, which again is weird. This is backwards. But the number inside the parentheses will actually shift your graph left or right. The number outside of your graph, if you are adding a number outside of the graph, that number will shift your graph up or down. This one moves like it's supposed to. If you see a plus here, that's going to shift your graph up. If you see a minus here, that will shift your graph down. This value, if you are multiplying to the quadratic function, this is going to affect your stretch or your shrink. I'll talk about that in a little more specifics. More likely, though, if you see a negative in front of the a value, that's going to take your parabola and it's going to flip it over. If your a is negative, you're going to get a downward facing parabola. So if I asked you to sketch y equals x minus 3 quantity squared plus 4. Okay, my initial function, the vertex was here at 0, 0, but now we're going to shift. Remember, this number shifts you left or right. If that number is a negative, that's actually going to shift you, in this case, to the right 3 units. This number out here shifts you up or down. If you see a plus, that's actually going to shift the whole thing up. So we're going to shift up 4 units. So we're going to go right 3, up 4. Now, from there, so that's my new vertex. So in this case, the vertex of my function is the coordinate 3, 4. Which also means that if I draw that axis of symmetry, that's always x equals the x value of my vertex. So that's going to be at x equals 3. Okay. The vertex, we just kind of graph it based off of that 1, 4, 9. So again, typically from your vertex, when you square, you're going to go right 1, and then you square that, you're going to go up 1. You're going to go right 2 from your vertex, you square that, you're going to go up 4. You go right 3, up 9. Now that usually goes off the graph. So you typically from your vertex, you'll go right 1, up 1, you'll go right 2, up 4. Same on the other side. And that would be my vertex. If there's a number in front of your a, you multiply that to the y, and I'll show you what that looks like in case there is a stretch. but that's how you would graph your function. And that's how you would find your vertex and your axis of symmetry. So the vertex is 3, 4. So we had -3 here, +3 here, +4 here. That's +4 here. That's your vertex. Axis is always x equals the x of your vertex. Okay. They wanted us to sketch y equals negative x plus 2 quantity squared. Okay, again, the number inside of the parentheses shifts left or right. If it's positive, this is actually going to shift us to the left 2 units. Here we don't see a number outside being added. That's like saying +0. So this means we're going to shift up or down 0. We're going to leave my vertex on the x axis. We just shifted left 2 units. So this is my vertex. My vertex is going to be at -2, 0. Which also means my axis of symmetry is that x equals -2. Now, like I said, typically from my vertex, I go right 1, up 1, right 2, up 4, right 3, up 9. If you have an a value, you multiply that to your y's. So I'm going to go right 1, and instead of going up 1, I'm actually going to go down 1. Right 2, down 4, and I get now this downward facing parabola. So again, a negative a value causes your parabola to flip over. I'll do one more example. Now, as far as my shifts, I don't have any parentheses. I'm not adding or subtracting anything to the x inside of the parentheses. So that's kind of like saying, okay, x plus 0 squared. If you don't see a number being added before the squared, okay, then there's no shift left or right. Okay, this +1 is outside of the squared, so this shifts my graph up 1. So that's going to be my new vertex at 0, 1. And again, that axis of symmetry, that dotted line right up through the middle, is at x equals the x of my vertex. Now, like I said, the typical parabola from the vertex will go right 1, up 1, right 2, up 4, right 3, up 9. When you have a multiplier, okay, like this 3, what we do is we multiply that to the y value. So instead of going right 1, up 1, we're going to go right 1, and we're going to go up 3. Instead of right 2, up 4, we multiply that by 3, we're going to go right 2, and we're going to go up 12. So 1, 2, 3, 4, 5, 6, 7, 8. Way up here. It makes this really skinny looking parabola. And again, we would match it on the other side as well. So the bigger your multiplier, the skinnier your parabola is going to get. Now, they do throw some crazy problems into my math lab for you. Do remember that if you want to double check and make sure you're graphing correctly, you can always use Desmos to help graph. If you go to desmos.com, that is a free graphing utility. You can type your function into Desmos and it will graph it for you. Then you can match that up and graph it on my math lab to make sure you're not missing stuff. Okay. And that's it. That's all I've got. So if you have questions, obviously you can stick around and ask them. If you want to just stick around and you have questions for me, you can do that. I'm here till 8:15. That's when the class goes. But that's all the information I have for you. So if you're ready to check out, that's all I got. Do remember that the final will be next week. It'll go live for you to take on Monday. There is no test by itself over chapter 8. All you have left is the final. If you have not taken exam 3, the chapter 7 exam, you have to do that by tomorrow. Okay, but the final comes live on Monday. So anyway, make sure you make your appointment and have that ready to go. As far as that goes, again, guys, it's been great having you in class. I will have your exam 4s over chapter 7. I think I said 3 before. That's exam 4. I'll have those graded. I'll have everything caught up into SIS, hopefully by tonight. If not, definitely by tomorrow. I will get you copies of your tests back to you so you have them to study for the final. Anyway, like I said, if you've got questions for me, you can ask them. You can continue to email me. But other than that, that's all I got. So with that, we'll see you guys later.